All right, so let's talk about angular versus linear momentum and some do's and don'ts. The do's are going to hopefully help you guys remember some of the most important facts and help you guys be really successful on answering questions. And the don'ts is going to hopefully steer you away from some really common traps and mistakes that students make. So let's talk about one of the do's first. The first big do is we want to make sure that we use conservation. Whether we're talking about conservation of angular momentum, conservation, no, TION. Oh, gosh, that was embarrassing. Conservation. Yeah, I think that's right now. So I want to make sure that you guys are using conservation, and remember that when the times that you can use conservation is no matter what, when there's no outside forces. If we're talking about conservation of linear momentum, that's no outside force, period. And if we're talking about conservation of angular momentum, we want there to be no outside force that would cause a torque. But either way, you'll probably be hitting a lot of scenarios where you should be using conservation of angular momentum or linear momentum. If you're using it with angular momentum, usually the way that these problems look is that we have something that is going to alter our rotational inertia, which would then have the opposite effect on the angular velocity. So if rotational inertia increases, angular velocity decreases, and vice versa. If we're talking about a linear momentum system, then usually we have something where we have some initial momentum that then is two objects or one object hits another object, and the momentum after has to equal the momentum we had before. So for example, if I had two objects that were connected to each other and they pushed off, and one of them was bigger than the other one, the momentum of the first, or the momentum at the beginning would be 0. So if one of them moves off at m the one direction, the other one that's twice as big would have to move off with half the speed. And we can see it's the same general idea that since this object has a bigger mass, it must have less velocity. So you can definitely use these similar ideas that like more of this value leads to less of this value when you're using either angular or linear momentum. But what I don't want you guys to do, and this is the biggest no-no of this entire concept, is don't turn linear into angular, whatever. So linear momentum can never turn it into angular momentum. You'll see this problem. I'll talk about it a lot. There's a homework problem that you guys are going to do tonight on it, that if I have some kind of a long object with a small object moving towards it, and it hits like the end, that's going to apply a torque during the collision. And if we want to describe what's happening here, often students say, well, we have linear momentum here because I have some kind of obvious MV, but later as that stick or whatever starts rotating, now I have angular momentum. And you're not wrong. There is linear momentum here, and there's not angular, and there is angular momentum here, but it's not linear turning into angular. They're totally separate ways of looking at the way that the world works, and so you always need to treat them totally separately. So in this case, we would have linear momentum before and possibly linear momentum after, as long as there's no outside forces that keep one of these objects from being able to move in straight line type manners. And we will also conserve angular momentum as long as there's no outside forces preventing the torques within this system. So they're totally separate. Don't ever turn linear into angular. That's always a trap answer if it says linear momentum turns into angular momentum or vice versa. So be really, really careful with that. If you do want to make a comparison, though, and this is where it gets a little bit dicey, you can compare. I'm sorry, compare is the wrong word. We can write angular in linear terms. And this is one of those like shadow equations that's not on the formula sheet and they'll never talk about, but they kind of expect that you have some ability to come up with it on your own if you need to. So if you want to memorize this, feel free, but otherwise kind of pay attention for the next couple minutes where I explain where this formula is going to come from. So angular momentum is it is L equals I omega. But I could be written as something that looks kind of like mr squared. There is this other constant that could be there, the 1/2, the 2/5, whatever, but I'm just going to ignore that just for a moment, just because like that doesn't really matter too much to what I'm trying to share with you guys right now. Omega could be written as v over r. Angular velocity can be written in linear terms, which we've talked about in other videos. So I could simplify this down, and it ends up looking like mvr. Notice that basically all we've done to turn angular momentum into linear momentum is we multiplied by the distance from the center of rotation to wherever like the center of mass is. So you can't use this all the time. It actually works best in a problem like the one that you guys see above, where if I'm trying to turn this what looks like linear motion of an object and describe it in rotational terms, if we say that this is the stick that's going to be rotating at some point, we can describe its angular motion because it does have a changing theta there. We can describe its angular momentum using that formula right there, which is the linear or the angular momentum could be written as mvr. So just be aware that we can kind of throw that r onto the linear equation and basically turn linear momentums into a new way of looking at them as angular momentum. But it's not linear turning into angular. The linear still exists. I can just describe it as angular by multiplying by r. So if this still exists, we still have linear. If this still exists, we still have angular. This did not turn into that. We've just found a new way to write angular momentum by using some of the more linear variables. So hopefully that helps. And thank you for watching.